Hi everyone, from today onwards we are going to start solving backtracking problem in blind 75 series. As the first problem, we are going to solve combination sum. This is a pretty basic and classical problem in backtracking. And if you guys don't know about backtracking, don't worry. I'm going to explain this very deep down and very easy so that you're going to understand what is the core concept of backtracking and how you can apply to any particular problem. If you watch this video for 5 to 10 minutes, you will understand how backtracking works, as well as you can apply to the any problem you're going to tackle in the future. Obviously we'll see 2 to 3 problem, but there is a lot of different pattern over there. But what you're going to learn in this particular video going to act as a base and core concept for upcoming problem you're going to solve in backtracking sheet. So without wasting much time, let's get started. The problem statement is pretty simple, guys. So we will be given a list of number that are said to be unique, which means we are not going to get any kind of duplicate values in a given nums. As well as we'll be given a value called target. And what the question asks us to do is nothing but we can pick any number from the nums. For example, I can just pick any number from this particular list. Once I add this up, I just need to get this particular target. I just need to find that particular combination. And you can take the number as many times as you want. You can take the same number 2 times, 3 times. It doesn't matter. You can take unlimited time. Your goal is nothing but you just need to find the target value once you just sum this up. To make this better understanding, let me pick some combination like 2, 2, 5. If you just add this up, okay, if you just add this up, you will get value 9. Am I right? This is one possible combination from this given nums I can make, which will give the target value. And there is one more combination I can also do, which is directly I can take number 9, which will obviously give the target value. And is there any possible way, guys? Yeah, you can tell me that 2, 5, 2 also gives you 9. Yeah, you are right. But the question asks we should not return any kind of duplicate value. So how to identify duplicate is nothing but they're given an equation itself. So if the two combination have the same frequency, then it's said to be that it is a identical one, which we should not consider. So what do I mean by that is, if you just draw the frequency map is nothing but how much time the number occurs. That's it. Pretty simple. If I just draw the frequency map, it will be like how much time 2 is used 2 times and 5 is used 1 time. Am I right? For this also the frequency map will be like 9 is used 1 time. And for this, if I draw a frequency map, again 2 is used 2 times, 5 is used 1 time. Now if you just compare this frequency map, these are unique. So what I need to do is that I should neglect this particular combination. I should only take this particular one. Okay, this will not be considered for the result. That's why you can see the output value 2, 2, 5, 9. Now let's move to the approach. So before getting into the actual solution for this particular problem, I just want to talk about what is backtracking and what are the core concepts you just need to keep in mind before solving a backtracking problem. So first of all, backtracking is pretty simple in nature, guys. It is just a better way of solving brute force problem. Brute force is nothing but a refined version of brute force solution, guys. So how does it differ from brute force is nothing but, for example, let's take a real life example. Okay, so you just need to go, let's assume this is a ladder. Okay, now you're just standing at this particular position. Now you can either jump 2 times or 1 time. Okay, either you can go one step by step, or you can just go 2 step, then 1 step, then 2 step. Like that you can go it. Just assume like this. And your task, your goal, within minimum number of steps, you just need to reach the top. Okay, the goal is nothing but minimum number of steps to reach the top. This is the question. And if you just think normally, how you do, guys, tell me how you will do. What I will do is that I will just go 1 step, 1 step, 1 step. This is the normal brute force. Am I right? How much step it took me? 1, 2, 3, 4, 5. It took me 5 steps. The first possible thing is 5. Then what I can do, the next possible thing is that I can just go 2 step ahead and 2 step and then 1 step. Am I right? Right now, how much step it took? 3 particular step, right? I'm just trying all possible ways. Now let's apply some constraint for this particular problem, guys. So there will be a step where we can just fill down. Okay, now at the beginning of the question, it's just a normal step. You can just climb it up. But right now, what I'm telling is that in this place, you just have a stone. Okay, let's assume you just have a stone in this particular place, which means you cannot climb this up from this particular step. Okay, just assume there's a stone over there. Now, how this thing will go is that first you will start from this thing, right? We'll just go step by step, 1, 2, 3. And now if I try to go next step, it will not possible. Am I right? What I can do at this particular step is that I can just come backtrack. Remember the word backtrack. I'm just coming back to the step. Instead of taking 1 step, I will directly take the 2 step. Now this point, I was not able to move to the next particular step. So what I'm doing is that I'm just coming back. Okay, note this point. I'm just coming backside and I'm just taking 2 step right now. Now I can reach this particular step. How does it work is 1, 2, 3, 4. That's it. Pretty simple. I'm just avoiding this particular step. How do I know that? Once I go this particular place, I will come to know that I cannot move it. So I'm just coming back and I'm just jumping 2 step. What is the thing we have is that I can just go 1 step right. I can go 1 step or 2 step. So instead of going 1 step, I'm just coming back and just taking the 2 step. That's it. I hope you guys understand what is basic backtracking is. Whatever I'm doing is just a brute force solution, but I do have an ability to come back and do a different choice. That is the most powerful thing about backtracking. It is just a refined version of brute force solution, guys. That's it. Now, I think you have some clear understanding about backtracking. This is one of the easiest explanation I can give. I'm not sure if any other explanation is there. So now let's talk about 3 golden rules for backtracking. This is very, 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 very important. You just need to note this particular thing. It's very important. You can apply this rules to any backtracking problem and solve this very easily. The one key concept is you just need to understand the pattern in backtracking. And once you understand the pattern, you can simply apply with this particular goal. Tadan, problem is solved. And in BSA, I think backtracking is one of the difficult concept, the most difficult concept. But if you just understand this basic rules, then backtracking will be pretty much easy. I have solved many backtracking problems and I just learned a pattern and I just made this 3 golden rule. So now let's talk about 3 rule, guys. The first thing we just need to notice about goal. So what you're trying to accomplish and how does your complete goal looks. You want to think about how your goal looks. Okay, that is what a goal means. If you just correlate with this particular example, what does our goal need to look like? My goal is to reach the top step. Am I right? That is my particular goal. That is what the first rule tells. Then next rule is decision, or I can tell it as a choice. What decision I can make at each particular step. At each step, what are the decision I have? If you just align with this particular step, a particular problem, at each step, I can either take 2 step or 1 step. These are my 2 decision, right? I can take 2 decision at any particular step. From this step, I can take either 1 or I can also take 2 step. Am I right? That is my decision. And constraint. This is one of the main concept. This is very, very important because constraint is the one which determine whether we are reaching solution or not. The constraint is nothing but what condition or rule we must follow. Again, if you just align with this particular problem, I cannot run over a stone. I mean, there's a stone. I just cannot run over this particular place. This is our constraint. Note it down. This is our constraint. And what is our goal? Minimum step to reach the top. This is our goal. And my, what I tell, my choices are this thing. I can either two take or I can take one step as well. This is my conditions and this is my goal. And what is my constraint? If there is a stone, I cannot move to this particular step. I mean, from this particular step, I cannot go here. So this is my constraint over there. So these are the three golden rule. Just think goal is nothing but how does a complete solution looks, and decision is nothing but at every step what are the choices I can make. In this particular problem, I can take a two step or a one step. But depending upon a problem, you can just think a scenario. Like backtracking is very simple, guys. We just understand the problem and correlate with the real life example. You can easily find what is the goal, what is the decision, what is the constraint. Constraint is little difficult to find. So goal and decision are pretty simple, but constraint is little difficult, but you can able to find once you get used to it. And I hope you understand these three golden rules. Now, what you can do is that let's apply this three golden rule for our combination problem, guys. Now you guys going to tell me what are the goals, what are the decision, what are the constraint for combination sum. Now you guys have some better understanding about the problem statement as well as backtracking. Now you are going to tell me what are the goal, what are the decision, what are the constraint, and then we'll try to draw a recursion tree and we'll understand how to solve this problem. Now you're just going to tell me, guys, what is the goal? So what is the goal of combination sum? You just need to get combination of number that sums up to the target value. Am I right? This is the goal. This is the final goal looks. The final goal is nothing but you just need to return a list of, okay, let me put a list over there. A list of combination that sums up to the particular target. This is our goal. Am I right? And now tell me, guys, decision. Decision is also one of the important thing you have to make in every particular step. At every particular step, what is decision you can make? Let me take an example. I mean the same example, 2, 5, 6, 9. At every step, what is the decision you can take, guys? Tell me. Just think with your real life example, whether you can pick this number or not, right? Whether I can take 2 or not. If I can take 2, let me take it. If I don't want, I can just skip 2. I can move to the particular number 5. Am I right? There are two possible cases right now. You just found it. There are no other possible way, right? Only two step you can do it. Whether to take the current number or not. Or you can just skip this current number. I'm just going to move the pointer. These are the two possible steps you can have. Can you tell me, guys, is there any other particular way or any particular choice you can make for solving this particular problem? No, right? There are only one step, whether to take this particular number, whether to take the current number or skip it, like whether take it or skip it. These are the only two condition or decision you can make at every particular step. Am I right? This is very much important. As I said, defining the constraint is very, very, very important. Now, if you think about the base case or the constraint, so what if my combination exceeds the target value? That could be one constraint, right? If the sum of target, like for example, 2, 5, 6, if I take this is obviously greater than target value, right? Our target is 9. Target is 9. Now this is obviously greater than 9 because the sum is going to be 7 plus 6, 13. Obviously 13 is greater than 9. This is one of the constraint. So whenever I just get the value more than a target, I just don't want to proceed that particular thing, right? I just need to find the exact target. But if the target is more than, if the sum is more than a target, then it's useless to go to that particular thing, right? So my constraint would be if sum of nums, I mean the current combination, if sum of combination is greater than target value, I can just simply return, right? I can just simply exit. This is my constraint. Now we just define the goal, decision and constraint. Now let's see the approach how to solve this particular problem. Let's take the same example and we are going to draw a decision tree, guys. So let us define the state, guys, for the recursion function. So the state is going to be that I'm going to have the index number which will map to the current value. The next state is nothing but a combination sum. We just need to return a list of lists, right? That's it. This is the one for the combination, and I'm going to have the current value. I mean the current sum of this particular thing. These are my initial state. Now let's start the backtracking thing. So I'm going to start the 0th index. I'm going to have the empty nums, and my current value is also 0. I forgot to inform one thing, guys. Like whenever you just write the decision, you just need to know what type of action we should do, which it will be mentioned in the description, problem description. According to our problem, what action I can take when I choose take option. Tell me, guys. If I just take this particular number, what I can do? Tell me. According to the problem statement, I can take the number as many times as I want. Am I right? Tell me, guys. That's what problem tells us. That do you remember the 2 points the problem tells? First is I can take the number unlimited times. The second point is that I just need to find the unique combination sum. So the action, what action I should do for take one? Tell me. Stays in a same place. Stay in same place. This is my action if I take this particular decision. So tell me what action I should do for a no take condition, guys. Tell me. Pretty simple. I just need to move to the next index. This is the action I just need to perform for no take, and this action I need to perform for take condition. Remember this, and I just forgot to fill this up. Sorry. Now let's continue the dry run, guys. Initially, we are going to start at the 0th index. Am I right? Now I do have the two condition, which is take and no take. What are the action we just defined over there? If I want to take the element, I'm going to stay in the same place. Remember, same place. So there is no change in the index. So 0, but I will have the number 2 and the current sum is 2. Am I right? Now, tell me, guys, again, I do have two different state, right? Whether I can take the element, again I can take the element, or I can skip it. So now I'm going to take this element. So whenever I take, I'm going to stay in the same place. Note this point. But I'm just taking the particular element. So 2, 2, the current sum is 4. Am I right? So now again I do have two particular decision, whether going to take the number or going to skip the number. Again, let's assume I'm just taking this particular value. Stays in the same place, 2, 2, 2, 6. So let me skip this a little bit. Again, I do have the two step, which is take and no take. Again, if I take the element, I will be in the same place. The value will be 2, 2, 2. The total will be 8. Again, if I take the element, my things will be like 2, 2, 2, which will be 10. Do you remember what is the constraint we just defined? If the current value is greater than the target, we should just stop this thing. Am I right? So what I can do is that this is the beauty of backtracking, guys. Just note it down. Whenever there is no solution possible, what I will do is that I'm just going to traverse back. I'm just going to go back and try a different possible choice. Right now I know that if I go down this particular path, there is no other solution. What I can do is that simply go back and try no pick condition. If I just no pick, I will be on the first index with the values of 2, 2, 2, and current sum is 8. This will be my this decision, right? Again, I will have two different case. Let me rough this off. Okay. So if I take the first element, which is 5, am I right? If I take it, take, no take. What is the case? Tell me, guys. If I take, I will be in the same index and my value will be increased like 2, 2, 2, 5, which is resulting in greater than target, right? 13 is greater than target. So what I telling is that this path is also not possible. So I just go back. I will try no pick condition. If I just put this down, this will keep on going it. So let's skip this thing. Obviously, we will not able to reach any particular solution by this particular path. Am I right? You already have 2, 2, 2, which is 8. Now you just need value 1 to make this satisfy. Am I right? To make to equal to value 9. But tell me, is there any kind of one is there? So there's no one in this particular place. So it is pointless for me to go deep down and explain this particular step. Obviously, there will be no solution in this particular step, and there will be no solution. Now, again, the beauty of backtracking. I know that in this case, I cannot have any other solution. So I just come back to this step. And again, I will try to do backtracking in this particular path. So we just seen this particular side that tells that there is no other solution. If you try to do this particular case, you will never going to reach this answer, guys. So I'm just going to skip this part. Again, this tells that I cannot able to find any solution. So beauty of backtracking, I'm just going back. I'm going to try this particular step right now. In this step, we are going to get answer. Let's see how the answer is getting formed. If I don't take, what is the action I need to do? If I don't take the element, I just move to the next index. Am I right? That's what I'm going to do right now. Yeah, I'm just going to move to the next particular index. 1 comma 2 comma 2 comma current sum is 4. Now I have two different choices, guys, whether to take or no take the value. So now I'm just thinking to take the index value 1. So let me take it. I'm going to stay in the same place. Remember the action for take. I will stay in the same place. For no take, I'll just move the index by 1 for no take. Okay. So my sum will be 2 comma 2 comma 5. Now 9. We reached the target. That's super good. I just reached the goal. What I'm going to do is that I'm going to simply put this combination to the result value. That's it. It is like pretty simple. I don't want to go explore any other path. Am I right? I just reached the particular solution. And what I'm going to do is that now I just reached the solution, right? I'm going to put this in a result like 2 comma 2 comma 5 in a result. And again, I'm going to go backtracking. I'm just going to backtrack, go back. I will try to find another better solution in this particular path. Now tell me, guys, you already have 2 comma 2 and current value is 4. And is there any way you can get answer in this particular path? No, right? So let's not waste time on seeing all the particular path. So what we will do is that if you try to go this particular way, there will be no other answer. So obviously just traverse back, and again this entire thing will be visited. So what we'll do is that again we'll come back to this particular step. We will take no take condition. So remember, if I do the no take, the things will look like this. I'm going to rough this off. So the no take will look like this. I will move the index and the value stays the same. There is no other action for it. And now again I have two different choices, whether to take, no take. If I take the first index, then I will stay in the same place. Then I will add 5 to the array and the current sum as well, 7. Now no take. Now again, if I try to explore any other path, there will be no answer. So what I'm going to do is that I'm just going to backtrack and I'm going to try no take condition. For no take condition, I should move the index, right? I'm going to move to the second index and I'm going to try exploring the path. Again, take, no take. If I try to take the index 2, then my sum will be like this. 2 comma 2 comma 6, my value will be 8. And is there any other way I can get the target value? Nope, it doesn't. So what I will do is that backtrack it. I will try again this particular path. Obviously, I'm not going to get any answer from this again. So I'll just try all possible path. Then what I will do is that I'll just come back. And obviously, I will visit all the possible combination. This look like a brute force, right? Optimized brute force solution. We are just trying all different possible case, but when we just meet certain condition, like for example, in this particular case, I know that I will not get any further answers. So I'm just breaking the loop here itself. I'm just backtracking it and I'm just exploring a different path. So this is the beauty of backtracking. It is just a brute force one, but a refined version of brute force. That's it. Now let's explore this particular path, guys. I think this looked little ugly. I'm just going to rough this off. Okay, we just seen this particular path. Now we have to take no take. If I don't take the element, I have to move to the next index. Remaining things stays the same. Am I right? Again, I do have take no take. So let's directly go to the next possible answer, guys. So I know this side we won't get any answer. So again, I'm not going to take anything, but I will move the index. Still, my things will be there. And again, I do have two different choice whether to take the next element or not. I'm not going to go this side. So I'll just go no take condition 0. In this step, I will get one answer like take, no take, take, no take, take, no take. Now, if I want to take the third index, let me take it out. Value 9, my current value is also 9, which is equal to the target. Am I right? We just got one more answer. So let's just directly put this up. I'm going to put it in the result, which is 9. And we just, once we got the answer, we just reverse back and we'll try no take condition. Now I'll just move to the next index, which is 4 and empty, but there's no index 4, right? This is also one of the constraint. We just need to note it down. Actually, I was just keeping this for this particular scenario only. Now we just found one more scenario which is out of bounds. So there will be a second constraint which tells that if index is greater than the length of nums, I just need to break it or exit it. This is one of the constraint. So we just explore all this path and we'll obviously see this particular path. We see this particular path. In this video, I'm not going to explain this thing because it obviously take times. So you can just do this on yourself, guys. Try exploring all the path and you can try out different example as well, so that you will understand backtracking very much easily. Now let's see how to code this up. The code is going to be very simple. Now let's look into that. So I'm going to name this function. What is the input parameter, guys? Nums, and we're going to get the target value. Am I right? Now we just need to write a recursion function. So I'm going to just name this function as DFS. Before that, let me declare a result, and DFS will have the current index as well as the current combination and the current sum. Let me name this as a sum. So this is my state, right? I just defined my state in this particular place. You can see index, current combination and the current sum. So first I just need to fill out my constraint, right? Or you can just write a goal as well or consider anything. But right now, let me do for the goal. What is my goal? If my sum is equal to target, what I can do is that simply I can just put this array, the current array, okay, I'll just put a combination for better understanding. I can simply put result dot append the combination. I can simply push this particular combination. I can stop, break out the loop. Do you remember? Once I get the particular solution, I don't explore any other path. I just simply backtrack it. So just return. Now we just reached the goal, right? Now, once we done with the goal, we have to check for the constraint. What are the two constraints I told? If length of nums is less than the index. Okay. Whenever the index is greater than the length of nums, or we do a or condition, right? Or my another case will be that sum is greater than target. If either of this condition occurs, I just need to simply return it. So simply return. Now we have two different choices. We have to make two different choices, right? First choice is that I'm going to take the current number. What are the action for taking the current number? Stays same, right? we are going to stay in the same index, and we will add the element to the current combination and the current sum plus the value. This is how my state should look. So let me write it down. Again, I'm going to write DFS and my index says the same IDX, but I'm going to add the current value. So like nums of index, and pretty simple, I'm just going to add sum plus nums of I. That's it guys, pretty simple. This is like a take condition, the first condition, and my next condition will be no take. Am I right? Like no take. For no take, what is the case? Like index plus 1. Am I right? Index plus 1, these are the same value. So DFS of index plus 1 and nums will be, I mean the combination will be same. So combination comma sums also will be same. That's it guys, pretty simple. I can just close this particular recursion function, and finally I can simply call DFS of initial state. Do you remember? We should start with the initial state, which will be like 0 comma empty combination, and current sum is also 0. At last I can simply return result. This is the entire code guys. It's pretty simple. So now let's talk about the time and space complexity guys. Actually it is very difficult for us to tell the time and space for this particular problem. We cannot define it correctly like how we did in a previous problem. As a rough calculation, what you can do is that we know that it's going to be exponential when we are having the two different cases. So right now we do have two different choice. So the time complexity will be 2 power n. Am I right? There are two different cases and I am having n numbers. For every number I can make two different choice, right? For a particular number I can make a two different choice. Either I can take or no take. So the rough time complexity is this one. So we cannot define it very correctly. And this, if I want to talk about space, it's going to be big O of n. This n is for stack memory. You know, recursion function use stack to keep track of it. So space is going to be big O of n. The time is going to be roughly 2 to the power of n, because we have two different choice and we have to make for n numbers. That's it guys. This is the rough time complexity, and we'll meet again in one more video. Until then, keep practicing. Bye.